pancake. So I have a problem. I want to enjoy delicious breakfast foods, but because of this thing right here, I can't really do that right now. Now the solution you might think is very simple, just make your own pancakes at home, but I'm not a simple man. I want the best pancake. I want the epitome of pancakes. I want every pancake in a 5-mile radius to cower in fear when they see my pancake. But Jacob, I hear you ask, how are you going to make the perfect pancake? That seems impossible. Well, you would be wrong. By using the powers of science and chemistry, I can construct the world's best pancake. This video is going to be split up into 2 parts. The first is going to be the execution. This is when I'm going to be making the pancake and teaching you how to make it yourself. The second is going to be the research. This is where I'll be explaining why I did what I did and explaining the science and chemistry behind pancakes. Now let's go over to the kitchen. Alright, so today we're going to be making some delicious pancakes. For the recipe, we are going to need flour, sugar, baking powder, baking soda, salt, buttermilk, sour cream, eggs, vanilla extract, butter, ham. So the first thing you're going to want to do is mix all of your dry ingredients together. This includes 2.5 cups of all-purpose flour, a 1/4 cup of sugar, 2 teaspoons of baking powder, 2 teaspoons of baking soda, and a teaspoon of salt. Now all we have to do is mix these ingredients together. With that done, you need to do the exact same thing with the wet ingredients. These include 2 cups of buttermilk, 2 cups of sour cream, 2 large eggs, and 4 teaspoons of vanilla extract. Once we have all the ingredients in the bowl, we can start mixing them. With those ingredients mixed, we can now add them and mix them into our dry ingredients. The consistency that we're aiming for is something like lumpy but not lumpy, which is confusing, but let's see how it goes. There are 2 bowls and then the 3, 2, 1, boop, and they're together. It's as easy as that. Now let's start mixing. This is the griddle we're going to be using. We're going to put it to about medium heat and cover it with pan. After that, we're going to start pouring batter splotches onto it, about 1/3 cup of batter per each splotch, about 2 inches apart. These will become our pancakes. Let's get started. Alright, so I have the griddle set to medium, and it's about time that I start putting the batter onto the griddle. Let's just sit back and watch some pancakes cook.
Well, I'll be honest, I don't really understand, but I fell down the hill and I got glue on my hands and I got rackets on my fingers. Rackets on my fingers, I got rackets on my fingers and I just can't stop. Don't stop. I can't stop, I got a platypus controlling me. I got a platypus controlling me. Now let me sum it up, it was a strange set of circumstances.
They finished. They look pretty good, honestly. I think. They're pretty good too. You see, I would serve these if it wasn't 3 in the afternoon and everyone already ate lunch. So it actually came out a lot better than I expected, I'll be honest. Welcome back. So this part of the video is mainly just going to be me explaining what I did a couple of seconds ago, as I stated earlier. This part of the video is going to be going into the science and chemistry behind not just pancakes, but many baked goods. Now, as you know, this is a very important issue for me. I'm taking this very serious. As you can see, I dressed for the occasion. So let's just jump into one of the most important parts of baked goods. You've probably seen those videos of a bread loaf rising in the oven. Well, that's actually caused by a baking technique known as chemical leavening. You see, chemical leavening is a baking technique used to increase the volume of baked goods through the release of gases. This is to increase not the taste of our pancakes, but the quality of them. Not the sweet, but the fluff. The infamous fluff that those beautiful pancakes have. Almost all chemical leavenings exploit the same reaction. They use acidic and alkaline compounds to produce the gases. This equation is 2 molecules of lactic acid plus 1 of potassium carbonate. That yields 2 molecules of potassium lactate, a water molecule, and a molecule of carbon dioxide. I've drawn it out so it's easier to understand what I'm saying. These are the reactants of the equation, and I'll be moving them around until I get the products. The potassiums move over to the lactic acid. 1 hydrogen from each lactic acid will then leave to form something new with an oxygen from the carbon trioxide. Now we have our potassium lactate, our CO2, and our H2O. In the reaction, the acid is obviously the lactic acid, and the alkaline is the potassium carbonate. In the 1900s, bakers used yeast as their chemical leavening. Yeast is slow. This is a problem for weak batters like our pancake batter because they cannot hold gases for very long. The long amount of time that it takes for the yeast to do its thing and the short amount of time that our batter can hold air bubbles is a problem. That will lead to some bad pancakes, which is why many modern bakers use a quicker leavening to raise their baked goods. Sodium bicarbonate is one of the most common alkaline components of chemical leavenings. It's also called baking soda, but see, the thing is, I want to sound smart. While effective, you have to remember that this is still just an alkaline component, and we still need something acidic to activate it. There are many things you can put in your batter that can activate baking soda, but one of the most common is known as buttermilk. To understand what buttermilk does, we have to understand what it is. It's a cream culture. A cream culture is a product intentionally seeded with a species of Lactococcus and Leuconostoc, which are bacteria, to make them taste better. They used to be made by letting milk sit overnight. Then they would skim the cream off the top of the milk. After, they would churn the cream, but things are a lot easier now. Centrifugal separators are machines that are made to separate two substances apart. Centrifugal cream separators are machines designed to separate the bacteria from the milk. True buttermilk is made using the low-fat portion of milk left over after the churning process. But we didn't use buttermilk, we used imposter buttermilk. Now you see, this is the buttermilk we use. Now you'd think it's just buttermilk, it even says it right here, buttermilk. But you see, if we look under the mustache, we can find that it is actually cultured buttermilk. What exactly does that mean? True buttermilk actually ran low near the end of World War II, and it's been low ever since. It was replaced with cultured buttermilk, which is fermented skim milk. You see, true buttermilk is much more subtle than cultured buttermilk. It also has a bit more of complex flavors. It is also more acidic than buttermilk. Because of the acidic nature of buttermilk, we can add it to our batter with baking soda to start the leavening process and raise our baked goods, which is good for our pancakes. But what if we could skip that process altogether? Baking powders are complete leavening systems. This means that they contain both alkaline and acidic compounds. These are in the form of baking powder and solid crystals. In post, I realized that it's supposed to be baking soda and not baking powder, sorry. The active ingredients are typically mixed with ground dry starch to prevent premature reactions. Now typically, when the baking powder comes into contact with the wet ingredients, it will dissolve in seconds. When baking powders are made with an even amount of acidic and alkaline compounds, you typically wouldn't see anything out of the ordinary. But if you add too much alkaline or don't stir enough, you can be left with gross pancakes. That's a big no-no for a perfect pancake. Now the whole point of baking powder is not having to worry about the batter rising correctly. But if your batter is too acidic or too soluble, you may have a problem on your hands. Let's look at cream tartare. It releases 2/3 of its leavening potential in the first 2 minutes of stirring. That's a lot of leavening potential. So what is the use of using cream tartare? We don't want our leavenings to work while we stir, we want it to work while we're heating it. This is why many supermarket baking powders are double-acting. Double-acting baking powders activate twice instead of once. The first time is during the mixing process, and the second is during the heating process. This process can only be activated with high amounts of temperature. Next, I'd like to talk about eggs, and it's really hard to do a smooth transition onto eggs because there are so many uses for eggs in baking products. For one, they can act as like a glue for your pancakes. As their proteins become more and more viscous, they begin to aid the shape and form of your pancake. Eggs can also thicken pancakes. Also, not balancing your eggs with the sugars and fats in your batter can lead to your pancakes becoming too chewy or too tough. This is a small note, but they can also have an effect on leavening. They can also have an effect on shortening. Shortening is a baking technique used to make your products more tender. This is by adding more fat to your product. Unlike many other things, egg yolks are more useful than egg whites for this. You can also change the moisture of your pancakes by controlling what parts of the eggs you use and how much of them you use. By adding more egg whites, you're making your pancakes a bit more wet, and by adding more egg yolks, you're making them more dry. They can also aid to the browning of pancakes. You know that beautiful brown color that they produce, but they don't cause it. That's actually caused by the Maillard reaction. The Maillard reaction can help produce a desirable color for our pancakes. According to Bakerpedia, the Maillard reaction takes place when sugars and protein-containing formulations are subjected to heat processing in the presence of adequate amounts of free water, alkaline pH, and some metals. This reaction occurs between reducing sugars, mainly glucose, and a main amino group, which can be just a free amino acid or a group on the side chain of a protein molecule. The recognizable contributors to this are lactose and glucose, but they include pentosis, hexosis, xylose, ribose, arabinose, galactose, fructose, lactose, maltose, lysine, arginine, histidine, and tryptophan. The process creates melanoidins, which can darken our pancakes and improve their taste. This is the process according to Bakerpedia again. First, the initial condensation of a carbohydrate carbonyl group with an amine, followed by a series of reactions leading to the formation of the Amadori product. Then the rearrangement, dehydration, decomposition, and/or reaction of Amadori intermediates to form the furfuryl compounds, reductants, and degradation products. Lastly, there's a reaction between the Maillard intermediary products to form heterocyclic flavor compounds and red or brown to black colored melanoidin pigments of high molecular weight. Now the next part's actually really interesting. I get to go into a bit of chemistry in this one. So we're going to be talking about why we added salt to the pancakes, which is weird, right? You see, salt molecules actually protect ion charges in the batter. So to know this, you have to kind of understand a bit about ions and charges in general. You see, ions have different charges, and those charges determine... So I was working on this in post, and I realized that this part was really complicated and like really boring, so I'm gonna try to liven it up a bit, okay? So you know what we're gonna be talking about. We're gonna be talking about salt. Okay. Salt changes the protein conformation because it protects the protein's charges. They dissolve to positive and negative ions. These sites become attracted to the sites that are of opposite protein charge. If a protein is made with a majority of positive, they will push away from each other and stretch. If you don't understand that, you will in just a second. So these are two positive ions, and they absolutely hate each other, and they're wait, where did it... Oh. So these two cannot be near each other without trying to separate. So this is when our good friend salt comes in. You see, salt's a Chad, and everybody likes salt. You know, these two are fine being close to each other if salt's there. See, look how close they are now. This process allows molecules to condense. So this can happen with many proteins, but one of the proteins that have salt-protected charges is gluten. Because of its amino acids, gluten has a minor net positive charge. As stated earlier, when the charges push against each other, the gluten will stretch. But with the salt as a barrier, the gluten has more time to condense and become stronger. This will turn our gluten from this thing to this thing. And it's all because of our good friend salt. With salt done, we can now move on to the subject of more and more spices, the first of which is sugar. To define sugar, we have to find out what it's really made of. If we want to get really specific, we can say that it's made up of hydrogen, oxygen, and carbon atoms. Our table sugar, or a disaccharide known as sucrose, is made up of two monosaccharides known as glucose and fructose. Sugar has a really strong attraction to water, which makes them really soluble in the substance. They also form temporary but buff bonds with water molecules. This means that they help maintain moisture in our pancakes. Another form of flavoring for your pancakes is vanilla. Adding just a little vanilla to your pancake batter will give your pancakes a new sense of taste, and it'll give it a little bit of depth as well. You have to remember though that the more time you spend cooking the vanilla, the more the aroma will be lost. Their flavors come from many places, be it their phenolic defensive compounds, the sugars and amino acids, or the curing process. The defensive aromatics of the plant are stored in an inert state. They are also bonded to sugar molecules. They're released when harm is brought to the plant, which means good vanilla is intentionally harmed. After that, it is dried where it will concentrate and develop its taste. The harvest process is really difficult and only takes place in a couple countries, which makes vanilla incredibly expensive. I'm not going to get into it right now because it doesn't have much to do with our pancakes. The last bit I'm going to talk about is the maple syrup, the infamous maple syrup. Everyone knows maple syrup, so I'm not going to get into it much. As you may know, it is made with sap collected from trees. After that, the water is removed, and there are many ways that people can do this. It's actually really cool. Today, a lot of maple syrup producers use an energy-efficient form of osmosis to remove water from the syrup. Reverse osmosis devices can remove up to 75% of the water from the syrup. The rest is then boiled out until the syrup reaches a desirable concentration. Sugar is primarily made of sugars like sucrose and glucose, which give it its delicious flavor, and water. Syrup is also graded on a level system with A, B, and C. Grade A syrup is what we use in our pancakes, and grade B and C are reserved for cooking. This grading system is based off of color, flavor, and amount of sugar. Sadly, true maple syrup is incredibly expensive and is rarely sold at grocery stores. They're typically replaced with artificially flavored syrups. Hopefully my explanation taught you something today, but it's time for the final part of the video. Hi! So, the second part of my video is currently uploading itself to the rest of my video, and while waiting for that to happen, which is probably gonna take a solid hour, I thought I'd make my conclusion. So, did we make the world's best pancake? Probably not, but we sure did learn something, didn't we? Anyway, I hope you enjoyed my video. My works cited and the songs I used in the video are gonna be in the end card and the description. So I guess this is bye for now. Anyway, I probably have to go back to editing the video now, so bye.